For the very first time in human history, we are producing, manufacturing intelligence like production. Raw material comes in, a lot of genius goes into that box, and what comes out is intelligence that's refined.
You're listening to Gradient Descent, a show about machine learning in the real world, and I'm your host, Lucas Bewald. Today on Gradient Descent, I interviewed a guest that I've been looking forward to interviewing for quite a long time. This is Jensen Huang, who is the CEO and founder of NVIDIA, which, if you've trained a machine learning model, you've probably trained it on NVIDIA hardware. We get into machine learning and we talk about his views on what the future holds. This is a super fun interview and I really hope you enjoy it. All right. Well, thanks so much for doing this. We collected questions from our community. They had a ton. So there's more questions that I'm sure we can get through. So I'm going to get in my questions first. And
Okay.
I wanted to start with like the number one question I wanted to ask you, which I've always wondered about, which is I think almost everyone training machine learning models these days uses NVIDIA. And I was really curious about how conscious of a strategy that was, like when you started to think about it and how you made that happen.
It started when almost simultaneously three different research teams reached out to us, asking us to help them accelerate their neural network models. And it turned out the reason for that was because they were all trying to submit for ImageNet, the big competition. And so deep learning came into our consciousness kind of around that time.
And what year is this?
This is when was Alex's ImageNet?
Yeah, it must have been like 2011, maybe.
Yeah, I was going to say 2012 or 2013, but anyhow, it's something like that. And so, anyways, AlexNet, it was that year. But it was kind of around our consciousness around that time. The thing that was really exciting was we all know that computer vision was hard to do, and for Alex to have created a neural network, trained it on a whole bunch of data, and broken the record of computer vision experts, of which many of them were at NVIDIA trying to do the same, using human engineered features. That giant breakthrough caught a lot of our attention. And so computer vision, as you know, is one of the foundations of artificial intelligence. And all of a sudden, a giant leap happened. And when discontinuity happens in something that important, it really caught our attention. I think the difference between what happened around the rest of the world versus us is we took a step back and we said, what is the implication of this, not just for computer vision, but ultimately how software is done altogether? Recognizing that for the very first time, software is not going to be written, predictive features weren't going to be engineered or created by humans, but somehow automatically extracted out of data, refined out of data somehow, to recognize patterns, relationships, and somehow learn the representation of some predictive model. That observation early on caused us to ask the question, how does this affect the future of software? How does this affect the future of computer science? How does this affect the future of computing? How would you change the way a computer, if the way that you write software is different, then how does it change the way you would design computers? And if the software that's written is written by a computer versus a human, how does it affect the type of computers you would design? And so we had the good sense of thinking about it found from first principles, the implications for the entire field of computer science and the entire field of industry, and which ultimately led to asking the question, what about the implications to all the different industries? And so I think that the good fortune was we were interested in computer vision. We saw the gigantic breakthrough from Alex and of course Jeff Hinton and the folks at Toronto, and we simultaneously were working on it with several other labs at the same time. And so I think it was partly good fortune, partly having the sense to realize the profound implications to computer science, and then asking ourselves what the implication is for everything.
But I think one of the things that you've done amazingly well is just stayed dominant in this space. Like, you might have had a head start, but of course, lots of other people have, noticed that this is a really valuable space. And I've been hearing since maybe 2014 companies saying, hey, we're going to make the next deep learning, training GPU or TPU or something like that. But you've actually really maintained this ubiquity in the market. And I wonder what you attribute that to. Is it more the architecture of the chip, or is it more the software like CUDA and cuDNN, or is it something else that kind of keeps you ahead of the competition?
Well, uh, we're partly because the company was formed properly for this opportunity. We were always in the field of accelerated computing. If you go all the way back to computer graphics, all the way since the beginning of our company, this new way of doing application acceleration, domain specific application acceleration, of which computer graphics is one. Scientific computing and physics simulations and others is kind of another. Image processing, for example, is another. You could argue that deep learning is yet another. And so these different domains of applications, the company was started with that mission in mind. Now, in order to do accelerated computing, domain-specific accelerated computing, you really have to be a full-stack company. You have to understand what is the application, the nature of the application you're trying to accelerate. You have to redesign the algorithm, because the way that you would write an algorithm, develop an algorithm for sequential processing is radically different than parallel processing. And so algorithm engineers, our company has a richness of algorithm engineers. And you have to think about the system software and the systems differently, because the workloads change the bottlenecks. And so you have to think about system software differently. You have to think about systems differently. You have architecture chips differently. And so our company is fortunate that we are a full stack company that goes all the way to the research of algorithms. And that's what it really takes to be an accelerated computing company. But I think the advantage that we have is that we've been a full stack computing company for a very long time, and we had taken that skill set from computer graphics to imaging to scientific computing, and then when deep learning came along, it was a problem that our company was very adept at solving.
That's a good segue into a question a lot of people had that I have also, which is there a lot of tension between the needs of gamers and maybe crypto miners and scientists and people in deep learning? And how do you trade those off into a single chip? Like, how do you prioritize the different needs? Or maybe there's no tension because everyone has to do the same type of workload. I'm curious how you think about that.
Yeah, there's absolutely a tension, and I, for example, scientific computing, because it has a large body of historical code, and they could be in FP64. Whereas for consumer applications, FP32 is just fine. Whereas for deep learning, it's quite a large amount of different types of formats that could be used. Um, the nature of the processing could be a little different. Sometimes it's very dense computation. Sometimes it's a little bit more sparse computation. Ray tracing, for example, is very sparse. And rasterization, on the other hand, is rather dense. Image processing is rather dense. And you have different computation natures. You have different precision that you have to support. Each one of the industries have a very large number of applications that are in use that you want to support and be able to accelerate. And so each one of these industries are a little different. We try to build we build a GPU that is universal in the sense that all of these applications can run on any of our GPUs. And that gives developers a very large install base to target. They know that when they develop on our architecture, it'll run everywhere. The only question is, in each one of the processors that they run, is it better for scientific computing, or is it better for machine learning, or is it better for imaging or computer graphics? And we shape the size of those capabilities, those functionalities, if you will, for the different applications, different markets that we serve. So, in the case of GeForce, there is no FP64 richness, although it runs. It runs rather slowly. In the case of deep learning chips, it'll run computer graphics, but it'll run less well than GeForce, and so on and so forth. And so we we adjust the size of the functionality to the market that we serve, and in combination with the software stack that goes on top of it, we should be able to bring the best products for the use case. Otherwise, everything is universal and everything just kind of works. Computer graphics, scientific computing, training, inference. We really believe that developers ought to have the largest possible install base and not worry about whether the software is going to run or not. It should always run. The question is whether it runs to its fullest capability.
I see. Well, another question along those lines is, do you think radical changes are coming? In particular, do you think quantum computing is something like really relevant to you, like something that will be a practical reality in the next, like in our lifetimes or the next 5 to 10 years?
It will definitely be in our lifetimes because Lucas, you and I are still pretty young, and so we'll definitely see it. However, it's not likely to be in the next 5 years to be generally useful. On the other hand, the important thing is, and this is really the marvelous thing about machine learning and deep learning. We've really, in many of the applications, whether it's drug discovery or large combination planning and optimizations, pathfinding, for example, traveling salesperson problems, these type of problems that people have historically thought would need quantum computing, because of machine learning, because of AI, we've made giant leaps. I mean, it's not Moore's law type leaps. If you look at the body of work of your customers and our customers and the scientists that work in both of our companies, in the last 10 years, where Moore's law, if it was moving at full rate, would have increased performance by probably 100x. Many applications, because of machine learning and deep learning, it's improved by 1,000,000x.
Totally.
We've improved performance by 1,000,000 times. And over the next 10 years, I fully expect that because of a couple of different innovations between accelerated computing and the further advances that we're expecting in deep learning, and this new field called physics-informed neural networks, we're doing some really fantastic work there. In many areas in scientific discovery, we're going to see probably another 1,000,000x. And so 1,000,000x advance is something that's kind of hard to wrap your heads around. But we're going to see that in so many different fields, whether it's in healthcare or climate science or other fields of physics that are really important to us.
So, are you someone that believes that we'll see AGI in our lifetime? Do you think the singularity is coming?
Uh, I don't know about that. However, if we reframe the question just slightly and say, uh, will AI be able to do things that are much better than humans can? You and I both know that, in fact, if you reframe the question that way, AI in many fields are already superhuman. And I think the number of superhuman human skills that AI will learn over the course of the next decade is quite extraordinary. I doubt that there will be many manipulation tasks that are repetitive that robotics won't do better than humans, which is one of the reasons why there's so much work in surgical robotics. Their hands will never shake. They'll be able to make the most minute and the most precise of incisions, and its perception ability is going to be incredible. And so I think that the coming years we're going to see superhuman AIs. They won't be like us, but in many fields of many domains of activities, they'll be quite incredible.
But I imagine where you sit, you're watching AI help with chip manufacturing and design better chips, and you're probably seeing that have compounding returns, which I think is sort of the thesis behind the singularity, right? It's sort of AI starts to create AI. You just see this exponential.
That's exactly right. Look, we're not going to be able to build next generation chips without AI, and that's kind of a remarkable statement. that all of the chip design process, the architecture process, and today we have 5 of the world's top 500 supercomputers in our company, and we are producing software that gets shipped with all of our AI chips. And without AI, we can't produce software that runs the AI. And in the future, without AI, we wouldn't be able to design the chips that we use to run AI. And so that's right. The circular positive feedback system is about to go into turbocharge, and so I have every confidence that the next 10 years we're going to see even greater advances, not necessarily at the transistor level, but absolutely at the computation level.
Do you have any concerns about, as compute gets more and more important to advances in science, that there's impact on the climate or even impact on access of who's able to make scientific discoveries or who's able to kind of make the next really exciting company if they need a supercomputer to do that?
First of all, one of our greatest contributions to the industry is we democratized scientific computing. Because of NVIDIA GPUs, the breakthroughs for AlexNet wasn't a supercomputer in the cloud, it was a GeForce card. Totally. Simultaneously, researchers around the world were buying GeForce GPUs, and because architecturally they're all the same as the supercomputers we're building, they were able to use that to discover the next the breakthrough that we're all enjoying today. The same thing is happening in so many different fields, and so I'm really proud of the fact that we've democratized high performance computing. We put it in the hands of any researcher. They don't have to go get gigantic funds to be able to do their research. One of the researchers, scientists that was in quantum chemistry, said to me one day that he had learned from his son, who was working at one of the computer companies here in Silicon Valley, that he should go and buy our gaming cards and download the CUDA SDK and port the quantum chemistry software that he was running on an IBM supercomputer onto our gaming GPU. And he was so amazed how fast it was. He had to wait for the rest of the week for the supercomputer to finish so that he could compare the software, to compare the results, that it was the same. And then he went and bought as many GPUs as he could from the retail stores and made himself a bespoke, a homemade supercomputer.
That's awesome.
And he said to me, Jensen, because of your work, I'm able to do my life's work in my lifetime. And in a lot of ways, we built him a time machine, and he was able to see the future in a way that otherwise couldn't. And so I think the first contribution is we democratized scientific computing. The second thing that we did, because of artificial intelligence and this idea of pre-trained models and transfer learning, we now have the ability to essentially have large companies pre-train intelligence. It's almost like creating a whole bunch of new college grads, super well-educated college grads that are now going off into the world that people can then adapt to their particular skills. So in a lot of ways, Lucas, the work that you do, the work that I do, what we've done is we've actually lowered the bar. We've democratized intelligence. We've democratized computer science so that almost anybody can download a pre-trained model and perform superhuman capabilities for their application domain by retraining it, by adapting it, by applying a transfer learning capability to it. And so I think it's artificial intelligence is the most powerful force that has come along, and one of its benefits is going to be to democratize computer science. Now, one of the things that you mentioned earlier about energy, I think that one of the greatest projects we're working on is this thing called Earth 2, which is which we're going to try to build a digital twin to mimic the climate of the Earth. It's a multi-physics problem, thermodynamics and fluid dynamics and chemistry problem and a biology problem and a human driver problem and economics problem, and all of it contributes in this geometry aware, because terrain matters, and multi-physics, mesophysics, mesoscale problem. And we finally might have the necessary algorithms to be able to take a swing at this and build a full-scale digital twin of the Earth, and hopefully uh, inspire us by giving us a model to test our mitigation strategies and our adaptation strategies, and simulate whether the technologies we're going to use to absorb carbon or reduce carbon emission will have the necessary impact a decade, 2 decades, 4 decades from now. And so if not for deep learning and the work that we're doing, that wouldn't even be possible. I wouldn't even imagine doing it.
Cool. So one of the things I wanted to make sure I asked you, on a personal level, I guess, is that I've really admired how you've run the same company for a really long time, and it doesn't look like an easy company to run. I mean, there's like a lot going on and a lot of physical things, and it clearly hasn't just been this sort of like, kind of like rocket ship SaaS startup. And yet you seem very technically current. Like, it really does seem like you stay on top of trends and keep a level of technical depth. And I was wondering how you do that, like how you stay educated about, what's going on in scientific computing and machine learning and other topics.
Well, I'm a little sleepy right now because I was up at 3 o'clock reading, and um, there's just no other way. I think you just have to keep on learning.
You're just interested in the topic and you just find
I don't know.
time.
I don't know that there's. I wish, Lucas. I wish there was wisdom to pass. I paused for a second. Was there a secret? Nope. I think. I think partly, of course, is really where's the energy and the curiosity juice coming from. Um, of course, being surrounded by really bright people, you learn from them, which allows you to combine a lot of your own understanding, and when you decode a puzzle or you learn something new, it really gets you fired up. And so I think I one of the most important missions, the purpose of a CEO, is to create the conditions where amazing people could do their life's work. And uh, you know, I really take that very seriously, and I try very hard to create a condition where amazing people could come and be surrounded by other colleagues that are incredible. That I think contributes a lot to it. And then the rest of it, as a CEO of a tech company, you really need to enjoy learning about what's happening in your company, which is plenty to learn. What's happening around the industry, and see if you could, imagine a future that is better for everybody.
I think a big part of my learning process that's hard to do running a company is kind of tinkering and stuff. I'm wondering if that's, I think you're originally an engineer. Do you find time to ever write a little code or put something together?
Not for a long time, but we get to tinker through other people.
Mm.
And this is the wonderful thing. NVIDIA is now 24,000 people, and if I could tinker a little something with it, just with everybody, the amount of tinkering that's going around in the company is incredible. There's a phrase that I say. I reach out to my friends, and I really see them that way. I reach out to my friends all over the company, and we brainstorm a little something, and they go off and try something, and somebody else I'm brainstorming with, and they try something, and then and that's just, I guess, tinkering at scale.
That's super cool. I love it. Another question a lot of people asked. I'm curious. I think people originally think of NVIDIA as for games. Are you a gamer at all? Do you play video games?
I haven't played much games. I see almost every game that go by, because we get the benefit of uh, some collaboration that we do with just about every game company in the world. So when they're in the labs, people will tell me, and I'll run down and go check it out and play with it a bit. But the last time, probably one of my favorite games was when Battlefield first came out, and uh, my kids were teenagers at home, and they were both coming into their gaming age, and just the three of us playing online Battlefield was just incredibly fun. That was probably some of the funnest memories I've ever had.
That's awesome. Um, I'm curious. A lot of people, um, a lot of people have been talking about sort of like, supply chain issues and a global chip shortage. Is that something that's like on your mind a lot? Is that a problem for your company?
Sure. Yeah, sure. We build the largest chips in the world, and the most complex computers in the world. And DGX is a few hundred pounds. It's so heavy. It's the heaviest computer that's being built today. It is so heavy that it takes a robot to build it, like a car. Most computers don't have to be built that way, but DGX is a miracle of computing, and we built it completely from a blank sheet of paper. Wrote all the software and all the tools that went on top of it, and there's a lot of components inside. Especially something that's a few thousand watts is quite a miracle. And
Totally.
and so there are a lot of parts and all it takes is one diode or one voltage regulator to keep it from shipping. And so our NVIDIA supply chain is quite an amazing machine. And we know that artificial intelligence is such an amazing thing because we are producing intelligence for the very first time in human history. We are producing, manufacturing intelligence like production. Raw material comes in, a lot of genius goes into that box, and what comes out is intelligence that's refined. And so large companies are depending on us. AI is intelligence being manufactured at large scales. So the teams are working really, really hard to keep up with demand.
You've been running NVIDIA for quite a long time. I was curious how you feel like you've changed as a leader over the decades of running the company.
Wow. You're almost asking the wrong person. You could ask almost anybody else around me.
Fair enough. How has your experience changed, maybe?
Okay, all right. That's an easier question for me. Uh, the, when I was 30 years old, I didn't know anything about being CEO, and I did a lot of learning on the job. There were many management techniques that uh, were just really, really dumb, and I don't use them anymore.
Like what?
Well, um, okay, all right. So I'll give you a couple.
Awesome. Thank you.
The list of dumb things that I've done over the years is quite large. I mean, I could write a book. But for example, uh, I really, really wanted in the early days for the chips to tape out, and so I thought what we needed to do was motivate the engineers to tape out the chip, and so we had this thing called a tape out bonus, and that's a supremely dumb idea, and the reason for that is because if the engineers could have taped out the chip, they would have, and so putting that bonus there is unnecessary. On the other hand, by definition, they're going to be late. And when they're late, it becomes a demotivator. And so because they no longer can earn the bonus. And so the tape out bonus for all the CEOs that are doing it's a demotivator, not a motivator. It's a little silly. And I think the answer is a chip gets taped out when a chip is ready to be taped out. We can create the conditions by which great work can be done. We can be good listeners and eliminate obstacles for the team. We could be part of the solution by highlighting issues, recruiting, all kinds of things that we can do to help them reason about priorities and help them reduce the scope of their work and try to seek the minimum viable product instead of building such giant things. And there are a lot of different skills that we could have instilled into the organization, but the one thing that it doesn't really need is a tape out bonus, an achievement bonus, and because everybody's trying to do their best, and so that's one example.
That's a great one. What else? If you got others, I'd love to hear them.
I Okay, here's another one. All right. Um, well, I want to be diplomatic as well because there's so many CEOs that are out there. They could be using some of these techniques, and I hate to be critical of them. Uh, so this is not a criticism. I this is just my style. I tend not to do one-on-ones, and if there's anything that I need to say, I tend to like to say it to the team and the group that is working on it, so that we're all hearing the same things. I'm hearing the same things. Everybody else is hearing the same things instead of being translated.
Interesting. It's a really unusual perspective. I think a lot of people think you absolutely must do
Yeah,
one-on-ones. Do you do that across the company? Do you think like your reports and their reports
I
also?
don't do it. I don't do it, but I have many leaders who do.
Hmm.
And I don't criticize them for doing it. I just don't do it. And
Interesting.
the reason it's probably more important for CEOs not to is because you can't eliminate it completely, but you want to reduce the amount of Jensen told me or Jensen told me that
Mhm.
as a way to somehow steer a conversation that otherwise should have been done on merits. And otherwise, instead of my will somehow being translated and repeated and interpreted through a chain. And so if I had a particular objection towards something, I would say it to more than one person. And if I believe that in working with the rest of the company, a particular strategy or direction ought to be taken, I would tell everybody at the same time. And so I've worked towards this approach because I feel it's much more transparent. It puts knowledge and the access to information in the hands of as many people as possible. It of course attracts more criticism to myself. For example, I might say something to 10 people and it's the dumbest thing in the world to say. And it was a terrible idea. Couldn't be a worst possible strategy. But instead of saying it to one person, I don't get the benefit of refining my ideas and then broadcasting it and always be a genius. And so I would therefore in this technique, you need to be a little bit more vulnerable, and you need to be able to deal with the fact that every so often you said something that wasn't perfect. And uh, nobody holds me to a standard that needs to be perfect anyhow. And so after nearly 30 years, I've kind of worked my way past that. And so if I say something dumb, don't hold me to it. Give me a chance to change my mind.
Is it a different experience running a company where it feels like it's struggling versus now where the stock seems really high and probably everyone's feeling really good about the prospects? Do you have to do different things in those different situations?
Um, I'm never different. I don't think it's possible to find a correlation between my behavior and the stock price. And I would say for 29 years, my behavior and the way that I approach problems, the way I approach people, the way I approach our company, our work, exactly the same. There's no correlation whatsoever. And you just got to give me a second. I'll find all kinds of issues to talk about. so, so, so I've got nothing but problems. That CEOs are surrounded by problems, not good news. And so I happen to enjoy that. I enjoy solving problems, and so I completely separate the financial success of the company from the importance of the work and doing impactful work. And so I've historically always done that, whether the company is doing well or badly. When we're doing badly, particularly during the time when we bet the farm on accelerated computing, we wanted every single chip to have the same architecture that I mentioned earlier. The pressure on our financial performance was immense. But I was equally as enthusiastic then and believed as much in the future as I do today.
That's incredible. You don't feel the outside pressure at all, or are you able to sort of separate yourself from it?
Um, no, we as a public company, you're going to feel a lot of outside pressure, and some investors are really artful in expressing their displeasure and criticism, and some investors are understandably less patient. But it's our job to express the reason why we're doing what we're doing. CEOs have to be we have to be reasoned. We have to have a purpose by which we're doing something. If we're clear in expressing why we're doing something and our vision for it, and we genuinely believe it, my experience has been that people are willing to give it a shot. And so when we first started our company, 3D graphics, consumer 3D graphics didn't exist. even APIs for it didn't exist, and we had to go evangelize that. And it took longer than people thought. When we moved into accelerated computing for about 15 years, it didn't exist, and so it took longer than I thought. I thought it was going to take 2 years, but it took 15. And AI was the same way. I spoke endlessly about the importance of machine learning and deep learning. For the first 5, 6, 7 years, I think people just didn't get it, which is fine. That's kind of part of building a new market and building a new approach. You have to recognize that it takes time for people to come along. And so I think the industry has been really patient with us, and our employees have been very patient with me, and I've really appreciated it.
So what's the thing that really motivates you right now? Like, what's the purpose that you feel like you're serving at this moment?
Our the company doesn't have a mission statement, but nobody's confused at our company and what the mission is, and it really is as simple as do impactful work that takes a very long time to succeed, because it has to be hard for it to be meaningful for our people, and that we are the best in the world at solving. And so we seek those problems. I seek those problems. There are two areas that I'm super excited about right now. One area is recognizing that we in several domains have invented the intelligence capability, the technology of intelligence, whether it's in perception or speech AI or language understanding. We're now able to have some of these technologies that can do these things. However, ultimately, what's valuable is not intelligence. Ultimately, what's valuable is skills. That's we hire new college grads with lots of intelligence, but very few skills. And then we give them skills by adapting them to domains. And in a lot of ways, that's essentially what is missing right now is to take the intelligence technology and translate it into valuable skills. Valuable skills, whether it's driving autonomous vehicles, valuable skills like customer service and call centers and such, valuable skills like automated checkout. It could be automated skills like radiology, and put a radiologist right into the instrument. Mm. So there are all kinds of really valuable skills that we can now create. And so that's a big part of where our energy is right now, is how to take this enabling technology and translate them into skills that customers in the industry, developers, could then adapt for all kinds of different domains. So that's one, the large scale application of artificial intelligence. Second is the next era of AI. We've done a really good job with soft AI that's in the cloud, and recommending music, recommending movies, and next item in the cart, and so on and so forth. And it's really, really incredible. The thing that we would really like to do is to, if we want to take AI into the point of where people are and into this next phase of its journey, AI has to learn the laws of physics. And so many of the world's challenges, whether it's climate science or autonomous vehicles or manufacturing or whatever it is, the AI can't just make a prediction. It has to make a prediction that obeys the laws of physics, conservation of matter, conservation of energy, and such. And it has to understand a concept of synchronous time. It has to be working within our time. So there are a lot of these type of problems that are really impossible to develop that AI unless we have something that is essentially a virtual world that obeys the laws of physics, which is the reason why we built Omniverse. We built Omniverse so that several things could happen. It's physically based. It's distributed. It's very large. It has the ability to support very large models. And the goal is several folds. One, you could teach a robot how to be a well-functioning robot in this physically based environment. You could connect it to IoT systems, for example, running a robot hardware in the loop. And so it has the ability to be connected to the physical world and stay synchronized, meaning to build a digital twin. The concept of a digital twin has been around for some time, but in combination with artificial intelligence, the digital twin is going to have a profound impact on the future. And so I'm super excited about these areas. One is just the application, and then the other is the next phase of AI. And that's what Omniverse is all about.
Yeah, I totally agree that things like Omniverse really critical for making robotics work. It sounds like you're interested in getting yourself, I mean, your company closer to the applications of AI. Is that right?
We'll stay a couple of clicks away from the actual application. But what we would do is we would create an application framework for people who are building applications to build applications.
I see.
And one of the application frameworks that I'm really excited about created a little demo they call Toy Jensen at the last keynote. And basically, it's a robot, but it's a virtual robot, otherwise known as an avatar. It has computer vision, it does speech AI, it understands language, so on and so forth. I'm super excited about that because in the future, many applications, we really need to go into the application to experience it, whether it's a virtual factory or virtual hospital or whatnot. It could be for entertainment like metaverse and the next generation, the next era of the internet. You want to go into that world, and the way to go into that world is through a wormhole called VR, and so we can go into that world. We could also have those agents come out of that world and to collaborate with us, and so they would come out through the wormhole called AR and be in our world. But otherwise, the metaverse is enjoyed using my favorite display, which is a computer display. People think that you need to wear head-mount displays for the metaverse, but it's further from the truth. The metaverse will be enjoyed largely on 2D displays.
Interesting. Well, look, we always end with two questions, and I want to make sure that I get them in. So the second to last question, and you've touched on some of these topics, but I'm curious, when you look at machine learning, do you feel like there's a question that's underexplored, like you would recommend to like a grad student to look into, or if you had more time, you'd like to spend some more time investigating?
Well, some of the research work that's being done right now, there's so many smart people doing this, and they're working on it because it's really important. The self-supervised machine learning approaches that are multimodality, Lucas, that's going to drive the living daylights out of both the tools that you're building, the platforms you're building, and the platforms we're building. And so multimodality AI, where you have vision, the vision doesn't have to just be images; it could be video, it could speech and natural language. That's going to take perception to a brand new level. I'm super excited about that. I'm excited about zero shot learning, and to be able to learn from whatever you're trained on, plus the priors that you have, is really quite exciting and powerful. Um, I think that one of the areas that is being explored now is to reproject, to project, not to project the framework of graphs into the framework of deep learning or graph neural networks. Mm-hmm. Graph neural networks, graphs, of course, the relationship of things, basically is a structure that can describe almost everything meaningful in life. And so that's why it's so useful.
Totally.
But the processing of graphs is cumbersome, and the breakthroughs with DGL and GNN and geometric and all of that to project the graph into the framework, the constructs of a deep learning pipeline, puts it into our world where deep learning has been so effective. Mm. And so I'm excited about that, and I hope that a lot more people does that work. And then lastly, I think there will be more innovation and more design and more creativity that's going to be done in the virtual world than all of the creativity and design that has ever been done in the physical world. And so what people call the metaverse is going to be just brand new pioneering ground for manufacturing, for design, for artists, for entertainment of all kinds. And so I'm super excited about that. I mean, there's so many things to work on.
Awesome. That was a great answer. I guess our final question in the last few minutes we have, there's kind of this trope that machine learning, especially deep learning projects, almost never see the light of day, that they're way harder to manage than, traditional engineering. I'm curious, when you look across your customer base, what are the kind of most common issues that prevent machine learning from being, from really solving the problems that customers actually have?
Yeah, this is really great, and it's a great question. It's also one of the things I love most about your company and the way you think about this. The the there's a fundamental difference between the technology of deep learning and the harnessing of deep learning and machine learning to write software. The importance of the methods and the process and the tools, that is so vital. What could be described as ML ops is so vital. You have to understand not just the neural network architecture and be able to invent something that produces excellent results is of course groundbreaking work there already by itself. But a company, in order to take advantage of this, has to realize that in final analysis, this is an intelligence factory. You have to think of it kind of like a factory. That's the reason why the word ops kind of makes sense. It's a factory. You have the raw material coming in, which is the data. It gets transformed in the middle through a lot of stages of very complicated transformation, as you know, and which is one of the reasons why your tools are so popular. It's really complicated stuff, and be able to manage that workflow in a productive way to transform that raw material into ultimately an output that is neural network or otherwise intelligence at scale is quite a significant process. And because it's a fundamentally new way of thinking about computer science, we used to have just engineers do it. And I don't mean just in that way, but we had engineers do it. But now we have engineers backed up by giant supercomputers that are operating these incredible operations software stack that you build. And so the refining process, the continuous refining process, the validation process, the simulation process, that entire process had to be reinvented for machine learning, reinvented for deep learning, this is the reason why your work is so important, and you guys are doing a great job, and I really appreciate the work that you do, and all the researchers that you support, and all the workflows that you're making possible. But this is what every company needs to understand, that software development in the future is a bit of a refinery process. It's a refinement process. It's an ML ops process. It's manufacturing.
Well, thanks so much. That's really kind of you, and I'm touched. I appreciate it.
Keep up the great work.
If you're enjoying these interviews and you want to learn more, please click on the link to the show notes in the description, where you can find links to all the papers that are mentioned, supplemental material, and a transcription that we work really hard to produce. So check it out.